Hi, this is Algebra 1, Module 7, Lesson 1's practice problems. Here we are going to practice finding some of the key features of the graph, specifically a quadratic equation. So I'm going to make a point on the vertex and draw a dotted line for the axis of symmetry. I'm just going to do a line since I can't do dotted on here. Label the coordinates of the vertex and state where it's a minimum or maximum. Write the equation for the axis of symmetry. Got a lot of stuff we're doing with this. I'm going to start by drawing the axis of symmetry. I'm just going to do all three of these in the row to start with. So we're just going to work on the axis. So vertex is the lowest point. So right here looks like 0, 0. And I'm going to go straight up from there. And that's my axis of symmetry. Here it looks like it's on 4, 0, off just a tad. Nope, it's going, there we go. Okay. And then here it looks like it's like -1, my x. So I'm going to try to match that up here. Why it's not. It's really hard to get straight. I might just have to do what I got to do. Okay. And then we didn't quite get all the way to the bottom on this one. So I'll try to stretch it here a little bit. There. Okay. So now I can make a void, label the coordinates of the vertex. So vertex is at 0, 0. This is a minimum. And my axis line is x equals 0. Okay, let's do this one. Coordinates of this vertex is 4, 0. It is also a minimum, and its x equals 4. Mine, because it's going up from the 4. Here, vertex is at -1, -2. And this one is also a minimum. Notice how it's the lowest. And x equals this prime, it's -1. All right, let's do the next ones. Notice how these are flipped over. So I go ahead and looks like my axis of symmetry starts about right here. And it goes through -3. I think it's -3 there. Can I get this one? Maybe. There we go. This one looks like it's about right here. It goes through 1. Get it straight. I go through. I know I want it to go through 1, so we're going to do that. And then this one doesn't look like it's right on a line, but it looks like it's right between these two. So let's see if I can. I did a pretty good job matching in between. And I don't know what this is doing. I can't decide if I'm on the correct side. There we go. Ah, just very touchy. Okay, so now we go to typing it. So my vertex is at -3, 5. It looks like for this one. -3, 5. This time it's a maximum, and x equals -3 in this case. All right, this guy, my vertex is at 1, 3, it looks like. This is also a maximum, and x equals 1. My line here, I know I did a little bit crooked. I should do straighten it up and then scoot it over. Oh, you know, I think I have to select. Maybe let me select. It's better. Now I'm gonna just scoot it over just a tad. There we go. That's, well, kind of. It's hard to get it right on that line. There we go. Okay, back to focus here. All right, and so this one, so the vertex is a little tricky. It looks like it's between 1 and 2. So I'm going to do 1.5, and then looks like it's at -3 on here. This one is a minimum, and that puts my axis line at 1.5. A connection exists between the coordinates of the vertex and the equation of the axis of symmetry. So notice how my x-coordinate is -3. My axis of symmetry is x equals -3. Coordinates 1, x equals 1. Coordinates 4, x equals 4. Coordinates 0, x equals 0. So the connection is the x coordinate of the vertex is the value used for the equation of the axis of symmetry. Okay, look back at number 6, this guy over here. Try to find a way to find the exact value of the coordinates of the vertex. Test your method with each of them before. So we just said it was halfway between these 2 points because it looked like that was the lowest point. But if I also look, here's my axis of symmetry. This x coordinate is 1, 2, 3.5 away. This one is 1, 2, 3.5 away. This one's about a 1 3/4. This one is 1 3/4. This one is 1, 2 1/4. 1, 2 1/4. Look at that, how they kind of match. But this one's on the x, so that doesn't do much for me. 1 1/4, 1 1/4. So I'm going to say that my vertex halfway between the x-intercepts. I'm not sure if I can figure out where my x crosses. It looks like it's usually about halfway in between. All right, how many x-intercepts can a parabola have? Well, here we have 1, 1, 2, 2, 2, 2. So 1 or 2, definitely. 1, 2, or we actually could have none, right? We could have it so it's not touching that x-intercept. So the x-axis. So sketch a parabola that has no x-intercepts and explain what has to happen for that. So I'm going to go back to drawing. If I have, let me get we're going to make this one my x-axis. This one's my y, so we can see them better. All right, so I would have to have it like down here. That doesn't have an x-intercept. This guy up here doesn't have an x-intercept. So really, for this to happen, the parabola has to be completely above or completely below the x-axis, right? It's got to be all the way down below here or all the way above. All right, next page. We're going to do some matching here. So x squared plus 4. Choose the area model that matches. Well, I have an x squared. We assume these boxes here are x squareds. And here are 4 extra pieces on here. So this one would be D. Here I have x plus 4, and then I square it. Well, here's an x. And if I add 4 to the side for different ones, for individuals, before I square it, that would be B. Here are 4 x's, and then I square it. So here are 4 x's, and then I'm going to square them. So that would be C. And then that leaves A. There's 4 of my x squared. So here's 4 of my x squareds. A. All right, the table of values, the graph of f of x equals x squared is given. So compare the values in the table for g of x to f of x. And we're going to identify what stays the same and what changes. So we're going to try to figure out what we've done to do each one. Use this information to write the vertex form of the equation, graph g of x, and then describe how it's changed. So quite a few steps on this one. So to start with, let's just look at this first one. So I'm actually going to start by graphing. I'm going to stick with B because sometimes it's hard to figure out that equation first. So I'm going to go ahead and put -3 comma 2 and -2 comma, oh wait, -3, wrong direction. -3 comma 2, -2, -3, -1, -6, 3, 5, 6, 0, -7, and then I'm moving back up again, it looks like. Okay. So if I'm comparing this to my original up here, that starts at 0, 0. That's down at 0, 7. So that looks like it's 7 lower. Let's see if that works for the rest. 1 minus -6, that's 7 lower. 4 minus -3, that's 7 lower. 9 minus 2, that's 7. So in what way did the graph move? It moved down 7. Graph, went down 7. And so in my equation, if you think about when we did our equations, what part of that shows it? Well, we have the x squared, right? So x squared, 3 squared is 9, but then I took 7 away from it to get 2. 2 squared is 4, then I took 7 away from it to get -3. So what part of the equation shows this? The -7 at the end. Okay, so let's look at these next ones. So here, I've got -3, 11, -2, 6. Again, let's just go ahead and jump to the graph so we can kind of see what this looks like. So -3, 11. I'm going to actually move down. I'm going to do my x-axis right here. It's kind of hard to see on this little guy anyway. Okay, so -3, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, look at that. I timed that just right. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so -2, 6. 1, 2, 3, 4, 5, 6. Leave is right there. And then -1, 3. 0, 2. And then I'm going back up on here. Okay, so we're still on the y-axis, so it looks like we just shifted up 2. If I think about it, 9 plus 2 is 11. 4 plus 2 is 6. 1 plus 2 is 3. So what way did the graph move? It moved up 2. And so when I do my equation, I still have my x squared. Only this time, I added 2 to each one. And so what part of the equation talks about this? The +2 at the end. All right. So now let's look at this one. -4, 9. Let's just keep going over here. So I'm going to put this one back. Do my line down here because I've got some big ones again. 1, 2, 3, 4, and up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think is right there. Oh, nope. I think I'm off one. This is kind of hard to see. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's this guy right there. Okay, -3, 4, 4, 1, -2, 1, -1, 0, 0, 1. Oh, we're going back up again. Okay. So trying to be accurate with these. All right. So in what way did the graph move? It looked like it moved to the left 1. So moved left 1. So to get that over to a -1, remember we had to get that what's inside the parentheses to a 0 to get y to equal 0. So that means that we had to take that x and subtract or add 1. I'm just going to do, see, to the left was a plus, and that was to the second power. So let's look at this. If I take 4 squared, that'd been 16, right? -4 squared is 16, but I had to get down to 9. So, but if I do -4 plus 1, that's -3 squared, that's 9. -2 squared, 4. -1 squared, 1. So that does work. So what part of the equation indicates this move? The plus 1 in the parentheses. All right, so let's see what this one's doing. Okay, so here we are going to graph these again. Oh, I can kind of see my dark line on here. So I'm going to go ahead and go with this line. It's pretty dark. Okay, so 0, 0, 9. 1, 2, 3, 4, 5, 6, 7, 8. I don't have 9 on here. So let's go ahead and move this down 1. I'm going to go ahead and move it down to this one so that I can do 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. 1 is 4, 1, 2, 3, 4. 2 is 1. 3 is 0. 1 is 4. Okay, 4 is 1. And we're moving back up again. Okay, so this time we've moved to the right 3. So here we moved right 3, which means that means I had to get that to the 0. I plug in a 0, 3 squared is 9. So that means I had to do my x minus 3. We needed to move it to the right because I take away my x value, right? Double negative makes a positive, x minus a -1, x minus 3. Okay, so let's look. 0, -3 squared is 9. 1 minus 3 is -2 squared is 4. 2 minus 3 is -1 squared, 1. 3 minus 3 is 0 squared. 4 minus 3 is 1. We're good again. All right, so what part of the equation indicates this? The minus 3 in the parentheses. Okay, now we need to find some square roots. So in these, you actually want to take the square root of each individual on here. So remember, it takes 2 to pull it out of the square root. So ever how many sets of 2 you can get out of here. So 49 is 7 times 7, right? So I have 2 sevens, so the square root is 7. A times A, that's 2 of them, so I can take one out. B, how many sets of 2's do I have in here? I have 3 of them. So I can actually simplify this entirely to 7ab to the third power. Okay, so now this one, notice I have a squared and a square root. Those actually cancel each other out. So a squared cancels out a square root. Squared cancels out a square root. Squared cancels out a square root. Look at all these. Squared cancels out a square root. It doesn't touch anything in the parentheses, so I'm going to leave those alone. But because those cancel out, I'm left with x plus 13. Because they canceled out here as well, I'm left with x minus 16. Here, they canceled out. All that's left is 36x plus 25. Same thing here. Everything canceled out except for the parentheses. So that's 11x minus 7. Okay, so I didn't do this one because not everything is in the parentheses. So I have to take the square root of each thing, the 9, the m squared, and the parentheses. So the square root of 9 is 3. The square root of m squared, so these guys cancel. The m squared cancels out with the square root. So that leaves me with just an m. And then when I look at the parentheses, everything in the parentheses is squared. So actually, that cancels out with the square root as well, leaving everything in the parentheses. So I have to leave my parentheses because I have other stuff this time. Here I had nothing else. I could take off the parentheses. Here I still have a 3m hanging out. So it's p to the third minus q. But I don't need that squared anymore because it canceled out with the others. All right, that's it for this lesson. Thanks for joining us. We'll see you next time.